Okay, here we go, ladies and gentlemen, section 5.2. We're looking at trig ratios of acute angles, basically any angle as you go around the whole 360 degrees. Okay, so first of all, I'd just like to remind you quickly of what we're looking at here, right? So this is an angle in standard position, right? This being the initial arm, this being the terminal arm, okay? That being the radius, it's always going to be positive. This being our reference angle, always to the x-axis. We could be over in this quadrant here too, boom, like this, right, where that would be my reference angle. That's your y, that's your x, that's your r. It can be in any of those quadrants, okay? Just sort of breaking these things down into pieces. So you've got your x side as your adjacent, your y side as your opposite, and your r as your hypotenuse. Hopefully you can see that there is that relationship, the Pythagorean relationship, right? X squared or a squared plus b squared is c squared, or in this case, x squared plus y squared is r squared. And we can always solve for that r, or the hypotenuse, or the terminal arm, whatever that length is, as being x squared, square root of x squared plus y squared. I guess I should have pointed out here that we have a point right there. Okay, that point can be anything. It could be down here, it could be up there, it could be in any quadrant. All right, so this is just a bit of a reference so that we can apply this stuff to what we're looking at. So here we've looked at the three main trig functions, right? Sine theta, cos theta, tan theta. Sine being opposite over adjacent, or opposite over hypotenuse, right? Cosine being adjacent over hypotenuse, and tan being opposite over adjacent. So that's where these values come from. What might be new to you today are these things called reciprocal functions. Now, hopefully you understand what a reciprocal is, right? A reciprocal is simply a number flipped. So the reciprocal of 2 is 1/2. The reciprocal of negative 2/3 is negative 3/2, right? Notice that the sign doesn't change when you deal with reciprocals. It's only the numbers that flip, okay? So in this case, it's 1 over sine theta. We call that cosecant. I know it looks like cos. Just going to get used to it, okay? Reciprocal of sine is cosecant, reciprocal of cos is secant, and reciprocal of tan is cotangent. And these are the abbreviations we use. And you can see that all we've done is simply flip these, right? Y over r becomes r over y, x over r becomes r over x, y over x becomes x over y. So these, again, could be some useful tidbits of information for you. I'll leave it up here for a couple secs. If you want to write it down, I'd suggest you pause it because I am going to continue. All right? So I do want you to see that r is always positive in this case. The only thing that's going to change as we go around this thing here is in this side your x is going to be negative, right? And down here your y's are going to be negative. So that's going to affect the sign of these trig functions. Okay? And that's essentially what we're going to look at now. All right, so here we are. If you're given this situation here in quadrant 1, quadrant 2, quadrant 3, and quadrant 4, okay? Remember, this is the plus plus, so your x is positive, your y is positive, your x is negative, your y is positive, your x and y are both negative, your x is positive, your y is negative. So what I wanted you to look at here was, in this case, y over r, right? It's going to be a plus over a plus, which is a plus, right? Here, these are all going to be a plus here because everything is positive on this side. So all are positive, okay? All are positive. In this side, well, my y is positive, but my x is negative. So this is a plus over a plus. So that's a plus. This is a minus over a plus. So cos is negative. And this is y over x, which is a positive over a negative. Notice that that's also a negative. So we'll see that the only one in this case is sine is positive. Okay, that's the only one that's positive in this third quadrant, or second quadrant. You look at the third quadrant, they're both negative. The only thing that's positive here is your r. So it's negative over a positive, which is a negative. This is a negative over a positive, which is a negative. This is a negative over a negative, which is a positive. So in this case, we have, in the third quadrant, we have tangent is positive. Okay? So we've got all, we've got sine positive, we've got tangent positive. You can probably take a guess as to what's going to happen here. Even sort it out on your own because you're bright enough to do that. Your y is negative, so it's negative over positive makes this negative. Your x is positive, that's a positive over positive, which is a positive. And here it's a negative over a positive, which is a negative. And here we end up having cosine that is positive. Okay, so the trick is to remember how that works. Okay, so we're going to be looking at reference angles, and then we're going to want to know what quadrant it's in, because that will determine if it's positive or negative, or if it's positive or negative, we can determine which quadrant it's in. Okay, we're going to be going back and forth. So a couple points here that we want to point out is that R is always positive. Okay, that hypotenuse here that we're talking about, this R value right here, always positive, all right? And reciprocal functions have the same sign. So again, when we find the reciprocal of sine, it's going to be r over y, but it's still going to be negative here. R over x, but it's still going to be negative. So just like sine is positive, that means that cosecant is positive. Just like tangent is positive, it means cotangent is positive. And just like cosine is positive, it means that your secant is positive as well. Okay, in those quadrants. Now, how can you remember what is positive and what is negative? Well, there are a couple things that we can do. All sine, tan, cos. If we use letters, it could be A, S, T, C, right? A small Tibetan child is something that people have said. Some people call it the caste rule. I don't like that because it starts in the fourth quadrant. What was it? All students take calculus, or there are some inappropriate ones that you can make up for your own benefit, but ASTC is what you want to remember, okay? So ASTC, that is the order in which what it indicates what is positive. So here's another quick point that I want to get across. Sometimes, there's a relationship here between my sine and my cosine numbers, okay? You can see if you look at sorry, I keep sliding along here. These relationships here are something that I'd like you to be aware of, okay? I can briefly show you in a geometric sense that if you're trying to figure out when the sine and the cos are the same, that would, if this is your y and your x and that's your r, when is y over x going to equal, or sorry, when is y over r going to equal x over r, right? And hopefully you can see that that's going to be when it's an isosceles triangle. So here we go. When it's an isosceles triangle, so when these are the same, so that's going to be a 45 degree, right? And if you go 90 minus 45, that's 45. So sine 45 is equal to cos 45. Along with the same reasoning, geometrically speaking, if I have this situation where that's 30 and that's 60, and then I have this situation, or let me do another one here. And then let's put another one right below it, where I have 60 and 30. You can kind of see that these are sort of the opposite of each other. So sine 30 and cos 60 should be the same. Sorry, sine 30 and cos 60. And if you just want to make sure here, look, we go sine 30, sine 30, and we go cos 60, and we can see that they're the same. Or if we go sine 60 and then cos 30, we see that those are the same. All right, so these relationships here are something else that you might want to sort out. All right, so we've looked essentially at introduce reciprocal functions. Okay, we've looked at how we can find the sine, cosine, and tangent, and cosecant, secant, and cotangent of your reference angle. This indicates to you which of those are positive in which quadrant, and that will come up very, very soon. We start doing some questions, and this at the bottom shows you the relationship between sine and cosine, and the reciprocal functions as well, and the tangent and cotangent, okay? So what we're going to do right now is we're going to look at a bunch of questions, and I'm going to see if we can work through these together. So let's just get started here. Here we are. So let's say the terminal arm passes through 4, 3. So what we're going to do is we're going to draw a picture here. 1, 2, 3, 4. 1, 2, 3. You can see that that's going to be right there. Where this is 3, that's 4. Now, if you want to find all 6 trig ratios, and this is your theta right here, sine theta is equal to opposite over hypotenuse. You don't have the hypotenuse. Hopefully you can figure it out. This is a triplet, so it's 3, 4, 5, right? A squared, B squared, C squared. So sine theta is 3/5. cos theta is 4/5, and tan theta is 3/4. Okay, and similarly we can look at cosecant theta, which will just be 5/3. You flip that over. Secant theta will be 5/4. Just flip that over. And cotangent theta will be 4/3. Just flip that over. All right. Pretty basic to do. You should be able to do that in any quadrant with any value. Let's just have a look at another one. A terminal arm passes through -12, 5. Let's draw another one. Let's go -12 and 5. Let's just put that there. -12 and 5 is my point. Okay, we'll draw a line like this. I'm more concerned about the reference angle. Okay, because once I have that reference angle, don't forget that it's going to be simply 180 minus that value, right? If you're down here, it's 180 plus that value. Those hopefully are basic concepts that you can get from these graphs. Let's see if we can do this. So that's 5, that's -12, another triplet, so that's going to be 13. And we're looking at sine theta being 5/13. So then you can look at cosecant theta being 13/5, right? We can look at cos theta now, which is -12/13, and secant theta, we don't change the sign, we just flip the values. It's going to be -13/12. Then we have tan theta being 5 let's just make the whole thing negative instead of putting the negative on the 12. And then we can have cotangent theta being -12/5. Now, the question here would be, how do you find the angle, right? So let's look up here first of all. Obviously, this is pretty easy to do because we have the values, right? Sine theta is 3/5. So you go second sine 3 divided by 5, and you get 36.8 degrees or 36.9. Well, let's try cosine. Second cos 4 divided by 5. You get the same thing. Second tan 3 divided by 4. You get the same thing. Each one of those will give you 36 degrees. Boom, you're done. Okay, now that's in the first quadrant. When we start getting in the second quadrant, things get a little trickier, okay, because we don't necessarily, well, let's look at this. If I go second sine of 5/13, okay, so second sine of 5 divided by 13, it's going to give me 22 degrees. Now you can see that that's not 22 degrees. This isn't anyways. This is what I'm looking for. This is my theta in standard position, right? What this is giving me is my reference angle. Okay, if you actually want to find out what the real thing is, you have to go 180 minus that 22 to get the actual angle. What would happen if we use a negative here? Let's go second cos of -12 divided by 13. That gives me 157 degrees. In that case, it kind of worked. Okay, but what I'm going to suggest to you is never use the negative when you're trying to find the angle. So just go second cos of 12 divided by 13, because now you get that same value, 22.6, okay? The problem is, when you get down here, okay, or in these two quadrants, sometimes it's not going to work out. The negatives, what you need to do is figure out what is positive in what quadrant, and then sort it out from there. And always just use the positive values, and it's always going to give you the reference angle, which makes a little bit more sense. Look at this, tan theta is -5/12. Okay, so second tan of -5 divided by 12. That gives me -22.6 degrees. That would be down here. What the hell's going on, right? So the problem is tan can be negative in these two quadrants. So you don't really know which one it's going to be in, right? And just like cos is negative in these two quadrants. So you're not quite sure which it can be in. Sometimes it's going to give you the right number, sometimes it's not. So the idea is to just find the reference angle, because that will give you a better idea, and then figure out what quadrant you're in. Okay? We'll deal with that as it comes along. Let's just keep plugging along here. Now, sine of theta is 21/29. If you want to visualize this, it's in quadrant 2. It is your y over your r. So you can draw it something like this if you want. Sorry, let's make that square here. So this is 21 and 29. Okay. But don't forget that it could also actually be over here, 21 and 29, because it would be positive, right? It's positive here and it's positive here, but it has to specify which quadrant. So now we're looking at this one here. Find cos theta and tan theta. This side is the one that we have to find. And we find that by doing Pythagoras. So the square root of 29 minus 21 squared ends up giving us 20. Look at that, it's another triplet. So we've got 20, 21, and 29. So cos theta is pretty easy to find. It's 20 over 29. And tan theta is pretty easy to find right now too, because we've got the numbers. It's 21 over 20. So if you were going to look at the angle, this is technically negative, so that should be negative and that should be negative. You can also think about it this way. Look, all sine, tan, cos. Well, sine is the only one that's positive, so your cos and your tan both have to be negative, okay? So we can just rewrite it like this. Negative, what is it? Cos is 20 over 29, and this is negative 21 over 20. I wouldn't assign the negative to a specific top or bottom. I just put it up front. Okay, so yeah, we're plugging away here. We're plugging away. Let's try another one. If my cosecant is 3, and tan theta is less than 0, find sine and cos. All right, well, let's check this out. Cosecant, that's 1 over sine, right, is equal to 3. So that means that sine theta would be 1/3. Okay, so now, and it's positive, right? It's a positive 1/3. All sine, tan, cos. So it means it can exist here, and it's opposite, so 1 over 3, or it can exist here, 1 over 3. Which one of those is it? Well, it says tan theta is less than 0. Everything's positive here. Tan theta is negative here, so it's got to be in this second quadrant, all right? And now you can do basic Pythagoras, right? This is going to be 9 minus 1, so this is root 8, or 2 root 2, right? It's root 8, which is equal to 2 root 2. So now if I look for my sine theta, right, it's going to be 1/3. I already have that, okay. I'm looking for cos theta now. That's going to be 2 root 2 over 3. And then think about it, is it positive or negative? It is negative because it's in this quadrant, so boom, there you go. If I wanted to find tan theta, that would be 1 over 2 root 2, and it would also be negative. Okay, I don't care, negative on the inside of the bracket, outside of the bracket, doesn't matter. Just kind of all over the place. Here is the last question I'm going to do with you guys, okay? And then hopefully you can sort some stuff out in the book. 3x plus 5y equals 0. What the hell is that? Well, a couple different ways. Once you start seeing patterns, you might be able to do this a little bit quicker. But right now, what I want to show you is how would you solve this? How would you graph that y? Okay. Hopefully you'll remember that you make it equal to y. It's negative 3x. So then y is equal to negative 3/5 x. Okay, so it starts here. Always going to have to start at the origin. Otherwise, we can't use these lines, okay? Minus 3/5 means it goes down 3, and then 1, 2, 3, 4, 5, over 5, right? So there is my line, right there. That is my line. Okay, now it says x is greater than 0, so I'm looking at the positive side here. Okay, well, let's make a triangle where this is 5 and this is 3, negative 3, let's say. And you can work out through Pythagoras what this is going to be, right? It's going to be 5 squared plus 3 squared is equal to r squared, so that's 25. Plus 9, that's 34. So this is root 34. And then we can basically finish everything off, right? Find the 6 trig functions. Now, this point right here, you could have picked any point. You could pick 10 and negative 6, but why don't we just pick the most basic one, right? You don't want to pick, you want to pick the lowest multiples of them, so that's a reduced fraction, essentially. You'll be going to be reducing it at the end. So now let's look at sine theta, right? So that's sine theta right here. It's going to be negative 3 over root 34. Cos theta is going to be 5 over root 34. And then we have tan theta going to be negative 3 over 5. And again, if you want to find the angle, I would suggest simply looking at those positive values. Let's use the tan one because it's easy. So second tan of 3 divided by 5, boom, it gives you 31 degrees. So you know that reference angle is 31 degrees. So if you actually want to find the real angle here, it's, what did we say, 31? So 360 minus 31 degrees. Might be a lot of stuff here, ladies and gentlemen. Hopefully you can make some sense of that. Ask me any questions in class, and we will get you guys sorted out.